Good morning, everyone. Today we are going to present a music company database management system. Our group members include me, Jatin, Saurav, Hemant, and Deepam. This is the problem statement. The Newton Records has decided to store information about musicians who perform on its albums in a database. The company has chosen us to hire as database designer, and the following information have been provided to us. Each musician that records at Newton has a SSN, name, date of birth, sex, an address, and a phone number. Each instrument that is recorded has a name, category, price, and instrument ID. Each album that is recorded on the Newton label has a title, release year, album identifier, and the number of albums sold. Each song has a title, song ID, and number of downloads. A lyricist has an ID, name, date of birth, and sex. There is also a release group which publishes music albums. Each release group has an RID, platform name, and release by and release date attributes. These are the relationships between the different entities. I will be explaining in the ER diagram itself. So this is the ER diagram. The rectangle shapes are the strong entities. The oval shapes are the attributes of the strong entities. The rhombus shapes are the relationships between the entities, which have been categorized into 1 is to 1, 1 is to many, and many is to many relationships. Now, as musicians are poorly paid, so a house can be shared by many musicians, and conversely, a musician may live in exactly one house. A musician may play many instruments, and conversely, an instrument can be played by many musicians. A musician may perform many songs, and a song can be performed by many musicians. A musician may produce many albums, and conversely, an album can be produced by exactly one musician. We have a release group that publishes the album. So, a release group can publish many albums, and conversely, an album cannot be published by more than one release group. An album consists of many songs, and conversely, a song may appear in exactly one album. A lyricist may write many songs, and a song can be written by exactly one lyricist. Genre here is the weak entity as its existence is dependent on the song entity. Being a weak entity, it is in total participation with song. It does not have its own primary key, so genre ID is its partial key. So genre can have many songs, and conversely, a song can have exactly one genre. This is the enhanced ER diagram. In this, I have divided the release group into two entities, release person and release company. They are in disjoint with each other. So, an album published by a release person cannot be published by the release company. The release person has a special attribute called as the number of records released, and a release company has the special attribute studio location. The platform name, release by, release date, and RID are common in both the entities. Thank you.
Hello everyone, this is Saurabh Ongli and I will be talking about relational schema, how a structure of tables are created and how data is inserted into the table. So let us first talk about the relational schema. So here you can see the different structure of tables and how all these tables are connected with each other. So let us first talk about the musician table. In this table I have created SSN as a primary key, Fname, Lname, DOB, sex are the other attributes of this table. Since the multiple musicians can live in a single home, so that's why I have created H number as a foreign key, taking the reference from the H number of the home table. In the home table, I have created phone number, street, city as attributes and assigned H number as a primary key to this table. Since the multiple musicians can play a single instrument and multiple instruments can be played by a single musician, so this is M to N relationship. So that's why I have to create a musician place table. In this, I have created PLINSTID as a foreign key, taking the reference from the inst ID of the instrument table, and also created PLSSN as a foreign key that is taking the reference from the SSN of the musician table. Similarly, in this way, multiple musicians can play a single song, and multiple songs can be played by a single musician. So this is also M to N relationship. So that's why I have created musician performs table In this, I have created PESSN as a foreign key, taking the reference from the SSN of the musician table, and also created PESID as a foreign key, taking the reference from the SID of the song table. In the song table, I have created SID as a primary key. Downloads, titles are the other attributes to this song table. Since multiple songs can be written by a single lyricist, so that's why I have created SLID as a foreign key, taking the reference from the LID of the lyricist table. And multiple songs can also be put in a single album, so that's why I have created AID as a foreign key, and that is taking the reference from the album ID of the album table. In the album table, I have created album ID as a primary key. Title, sales, release year are the other attributes of this table. Since multiple albums can be created by a single musician, so that's why I have created AL SSN as a foreign key, taking the reference from the SSN of the musician table. And since also multiple albums can be released by a single artist or a single company, so that's why I have created ALRID as a foreign key, taking the reference from the RID of the individual artist and the company table. In the individual artist table, I have created RID as a primary key. Number of records, platform name, released by, release date are the other attributes of this table. In the company table, I have created RID as a primary key. A studio location, platform name, released by, release date are the other attributes of this company table. Since genre table is a dependent entity that depends on the song table, so that's why I have created a primary key that is a combination of genre ID, the partial key, and GSID, the foreign key, which takes the reference from the SID of the song table. The category and the popularity are the other attributes of this genre table. In the lyricist table, I have created LID as a primary key. Fname, Lname, DOB, sex are the other attributes of this lyricist table. Now we are talking about how to create the structure of tables. Here you can see the queries to create the structure of different tables. As for example, if you want to create the structure of the album table, then you have to write create table album, and in the parenthesis you have to write all the attribute names and their data types. And if you want to specify any attribute name as a primary key, then you have to write primary key and then the attribute name. And if you want to specify any attribute name as a foreign key, then you have to write foreign key and then the attribute names and then the references and then the table. And in the table parenthesis you have to write the primary key. That means from which primary key of the table the foreign key is taking the reference. Similarly, in this way we have created all these tables. Now we are talking about how to insert the data into the tables. For this, we have to use the insert command to add the values into the tables. For example, insert into the table name values, and in the parentheses we have to write all the values separated by comma. After running the above command, the data will be inserted into that particular table. Now you can see the data into the tables that we have inserted using the insert command. Thank you.
We will advance to the queries part. So the first query is show the information of all those songs which belong to the albums whose releasing company have released more than the 200 records. So first we will look into the inner query. What we have done is we have established a natural join between the two tables album as well as releasing company, where we are interested in fetching the records greater than 200. From this information we will fetch album ID, and from this album ID we will fetch AID from the song, and we will fetch all the details and display them as follows. Then show the details of the album whose musician lives in the Mumbai. First we will look into the inner query. From what we have done is from the table home we are interested in fetching the H number with the conditions where city is Mumbai, as well as the we have established the main condition, that is musician home number as well as home's home number. From this information we will fetch the required H number, and from this H number we will establish the connection between musician table as well as from home table. Now we will get the SSN ID, and from this SSN ID we will fetch the AL SSN, and from this we will get the in the album table we will display all the details as follows. Now show the name of instruments which fall in the instrument category containing at least 3 different instruments. First we will as usual look into the inner query. We will first select the category. We will first fetch the category from the table instrument. Now we have used the group by clause because we are interested in looking at least 3 different instruments. So we will fetch into the category where all those instruments they are at least 3, that is greater than 2. So we are getting an account of count from greater than 2, so that we can fetch at least 3 different instruments. From this we will fetch the required category, and from this category we will go into the instrument, so that which will print the corresponding name of the instruments, like this. Now, show the details of the genre having the song with minimum downloads. First, in this inner query, what we have done is that we have fetched the minimum downloads from song. Now, this minimum download should be corresponding to the this downloads, where we will get the minimum downloads, and from the corresponding SID we will fetch the gender GSID, and then we will print all the required details from the table genre. Then show DOB, first name of all the female lyricists whose songs have crossed 60,000 downloads. So in this inner query, what we have done is downloads should be greater than 60,000, as well as, because we are interested in the female lyricist, that's why we have established sex equals to F, that is female. Then first we will complete this query. After getting the required output, this will get into the input of this outer query. So select DOB and F name, the required details from the lyricist table, and then we have established a natural join between lyricist table as well as song, where we have established the condition downloads greater than 60,000 as well as sex equals to female, and then we are getting the desired output as follows. Then show the name of locations having at least 2 different releasing companies situated in them. So what we have done is we have established an equijoin in the same table, that is releasing company. So select R1 studio location from releasing company as R1 and releasing company as R2, because we are doing the self join, that's why we have explicitly mentioned R1 and R2 were 2 different entities of the same table. Then we are interested in looking R1 studio location equals to R2 studio location, because location will be same but the releasing company should be different. That's why we have established the condition R1 released by is not equals to R2 released by. Then by computing this query, we will get the desired output as R1 studio location. So it has printed Mumbai. Then next query is give title of the song whose lyricist is born after 1995 and has genre hip hop and is downloaded more than 10,000. So we are directly going into the outer query, that is we are selecting title from the table song where download should be greater than 10,000 as mentioned in the question, and then SID should be in select GSID from genre having category, where category is hip hop, because we are interested in looking at the category hip hop. Then in the lyricist table we will fetch the LID whose required DOB should be, that is born after 1995, and then from this LID we will fetch SLID, and from this inner query we will fetch SID, and by these combining these 2 conditions we will again go into this condition, that is download should be greater than 1000. By fetching all those conditions we will fetch a required title.